Yes. Yeah, no problem. Yeah, I'm just trying to change my vantage point. Sorry about that. It's a blind spot there, right? Okay, so with your team, I'll do with you guys, don't worry. Read your directions for Monica's sister from homework 392. I won't do that. Verify that everyone will obtain the same answer and prepare to share how you added the fractions in class. So we're just gonna talk about adding fractions, right? So if we look at this little blurb, now Monica's sister wants to know why. Why does she have to do all the steps, the common denominator? What is the fraction anyway? Why does that have to be so complicated? Draw some picture diagrams to make up some situation, blah, blah, blah. We'll just talk about how you add fractions. So just make it simple, right? So how do we add fractions?
You make the common denominator.
Yeah, totally. So you have 1 over 3 plus 2 over 5. So if you think about it, I mean, if you want to use like a 4th grade example or whatever, it's kind of like if you had like a glass, right? And the glass is 2/5 full. Say it's 2/5 full, right? And say another glass nearby, and let's say it's 1/3 full, right? And you mix one glass with the other, then what fraction is full, right? That's kind of what's happening here. Using an LCD makes the comparisons easy, right? Like, what if each of these glasses were 15 ounces? Yeah, there are 15 ounces. How many ounces do I have if it's 1/3 full?
5.
5, right? That's 5 ounces. How many ounces you got if it's 2/5 full? If you have 15-ounce glass and it's 2/5 full, how many ounces? 6, totally, right. So when you mix them, how many ounces you got now? So 11 out of 15. So if you visualize like that, and maybe I should talk 4th grade. I thought it was pretty good. No, but yeah, 11/15ths, right? So that's why we do LCDs, because we want to compare the fractions easily, right? So 3 and 5, obviously the LCD is 15, or at least a multiple, because 3 and 5 both go into 15, right? 15 is divisible by 3, 15 is divisible by 5. So then you multiply, you change the fractions in this manner. And the reason I change both top and bottom, so the fractions will hold the same value, because 5 out of 15 is still 1 out of 3, still 0.3 repeating. Or 2/5 is 0.4, you get 6/15, that's still 0.4. So you don't change, it's just a cosmetic change more than anything else, right? So then what do you got? You got 5/15 plus 6/15, which is 11/15. So again, it's kind of like, hey, what if I had 2 glasses? I want to pour one glass in the other, and I have the fraction of what fractions filled with liquid. When I mix them, how much do I got, right? That's how we handle it. So we do the same thing when you have variables, right? It's no different. Just it's not as easy to conceptualize as I did with like that schematic, but you do the same thing, right? So if I look at 398, right, and I'll have you guys try some of the other ones afterwards. So you have 2x over x minus 1 and 3 over x plus 5. Well, x minus 1, can I factor anything out of that? It is what it is, right? X plus 5, is there anything that can be factored out of that one? No, those are as basic as it can be. So when that happens, the LCD, or the least common denominator between both those expressions, is just the product of them. Just the product of them will be your LCD, because that's an expression that has x minus 1, x plus 5 built into it. Because is x minus 1 a factor of the LCD? Yeah. Is x plus 5 a factor of the LCD? Yeah. If you want to FOIL it, go ahead. It's going to be x squared plus 4x minus 5. Again, is x minus 1 a factor of this? Whoa. Is it a factor of this? Sure. Is x plus 5 a factor of x squared plus 4x minus 5? Sure. Right? So anyway, let's actually combine them. So I'll do it down here because I need some space. So you multiply top and bottom by whatever it's missing, right? Like, for example, this one needs an x plus 5 to make it complete. So you do the both top and bottom. This one needs an x minus 1 to make it seem complete. You do the both top and bottom. Combine everything, and you're set. If you combine everything, what do we got ourselves here? You got 2x squared plus 10x, right? And positive 3x minus 3. You guys see how I got that? I got that stuff in black. Does that make sense? And make sure you guys see that just fine. Hopefully, some glare. Here, just look at the shades. But yeah. And then the bottom, just leave it like this. You don't have to FOIL if you don't want to. It's not necessary. Just leave it like that. And then clean up the top, which is 2x squared plus 13x minus 3 over x plus 5, excuse me, times x minus 1. That's all. Now you got it, right? Pretty easy. That's x minus 1. Let me write that more nicely. If the top factors go ahead, rarely that's going to be a possibility. So don't worry about it. Just leave it like that and you're good. Why we have this process, you're going to be dealing with this stuff in other more advanced concepts or topics later on. It's just a skill that you need to have in your back pocket if you have to combine these for other kinds of problems you'll do, where this will be like one small part of a bigger problem. That's why we're doing this, in case you're curious. So questions on 398? All right, here's what I'll do. I'll kind of set up the other two, but how you guys use in your table groups, and then we'll do one more example, and then we're done. So for 399, what's the story here for that one? You got two fractions. Now, if you look at the left fraction, what's the denominator of the left fraction? Now, it's 3x plus 1 part of the second fraction. It is. So we'll include that, but we also have to have an x minus 5. So the first fraction is cool. The second fraction is cool. The first fraction needs something. What do we have to introduce to the second fraction to make it seem complete? Yeah, exactly. So I'm going to let you guys combine it. So I'll give you guys a little push here, but I'll let you guys do the rest. Then we'll share answers in just a moment. And then for the other one, draw a little barrier here. There's our barrier. For the other one, what's the LCD for the other one here? What do you guys think? For B, what would be the LCD for B? Right. But, yeah, because x plus 3 and x minus 3 are part of the first fraction. Only x plus 3 is part of the second fraction. In order for everything to seem complete, you need to have both x plus 3 and x minus 3. So I'll have you guys work that out as well. Okay, I'm going to freeze my screen and work it out. Give you guys a couple minutes, check with your table mates, and then we'll look at the answers. Oh, isn't this interesting? You guys may want to factor the numerator for part A after you combine like terms. The answer comes out to a very interesting answer. At least I think. I could be wrong. So you'll need to do some simplification with part A after you combine the fractions. Hmm. Okay. Here are my answers. Ask questions. So part A, I got x minus 2 over x minus 5. Even after I combine the two fractions, because I have to do x minus 5 to both top and bottom of the first fraction for part A. When I combine like terms, I got 3x squared minus 5x minus 2. And that was factorable. That was factorable. And it factors at 3x plus 1, x minus 2. There's another 3x plus 1 on the bottom of that fraction. Those cancel, leaving with x minus 2 times x minus 5. For part B, I could have factored out 3 from the top of the first fraction. I didn't do that, but I could have. That might have made things a little easier, but it's okay. But when I combine the fractions, so the second fraction gets x minus 3 to both top and bottom, because that's the LCD. When I combine them, I get 9 minus 3x plus 2x squared minus 6x, or 2x squared minus 9x plus 9 over all that junk in the bottom. The top is factorable. The top factor is 2x minus 3 times x minus 3. Well, you have a pair of x minus 3s, both top and bottom, that cross off, leaving with 2x minus 3 times x plus 3. So those are the simpler forms of those expressions. So the moral of the story is that even after you combine the fractions, even I said rarely can you factor the numerator. Well, I guess this is the rare cases where they were factorable. I guess they carefully thought through these problems. And so you have to look for that. So you're not just out of the woods yet after you combine the fractions. You do have to factor the top to see if it factors out with anything from the bottom, which is also important not to FOIL the bottom, because you wouldn't know that things would go away if you FOILed it, right? One other thing before I let you guys ask any questions or we move on. If you let x equal 1, just to see what happens, like if I let x equals 1, if I plug into the original fraction, the original expression for part A, if I plug 1 to the original expression for part A, what do you get? If I plug 1 into this guy, what happens? What does that first fraction become?
1 over 4.
And how's the second fraction?
4.
We have 2 minus 2. What's 2 minus 2?
0.
Yeah, so you get 0 over a bunch of junk. So it's just 1/4. Now, if I plug in 1 into that, the simplified form, what do I get when I plug in 1 to x minus 2 over x minus 5? I get -1 over -4. What does -1 over -4 become? 1/4. That should happen. If you did all the, of course you could plug in numbers incorrectly too, but if you plug in a random number and correctly into both original and simplified forms, they should be the same answer, and they are. That's how you know you've done it right. You can also graph, and they should be the same graph, but it's kind of hard to punch all into a calculator. Desmos, I guess, is a little easier, but still kind of hard. But you could graph. Let me do the same thing for part B and make sure I know I did it right. If I let x equal 1 here, and I chose 1 because it's easy to work with, unless it's undefined. So you get 6 over 3, I think. Is that right? No, 6 over 4. Is that correct? If I plug in 1? No, I lied again. If I plug in 1, I get 6 over -8. There we go. Plus 2/4. So you get -3/4 plus 2/4, which is -1/4. Plug in 1 to simplified form. Do I get the same thing? I do. I do get -1 on top. I do get 4 down below. But plug in 1 for x. That's how you can check to see if you did it right. Because sometimes you don't know. Like you leave the test like, I don't know. I think I did all the algebra right. That's how you build the confidence. Like, okay, cool, I've got this, right? And you feel confident, you do better in other problems, right? So anyway, that's just a little trick you can do to check your work. Questions now on 399. We're good? All right, great. We're almost done. We still got lots of class left. Okay, 3/100. With your team, decide how you can alter the expression of the fraction of a common denominator. Blah blah blah. Now I've already done so. Add fractions, simplify if possible. Repeat the process for another pair. Okay, you guys can do this in your table groups again. Do this in your table groups. I'll work it out. I'll walk around before I show the answers to make sure you guys are doing okay. Once we're done with that, then we'll do the homework quiz. I'm gonna freeze my screen again. Here we go. Yes, Ben. You give me 1 sec. I'll be there in a second. Wait, part C of this one right now? Yeah. Oh, let me work these out first, and then I'll. I talk about 3/100s. Are you talking about problem 100? Yeah, just give me a moment. Let me work it out. I'll come by. It's just overture.
Would you just these?
Actually, you want to factor first because you might be doing too much because they might share a factor. Definitely factor the denominator and then find the LCD afterwards. It's you want to avoid doing too much. Like I wouldn't just multiply those two denominators straight up. Like I would actually factor and only take what you need. Okay, just so I know you guys are on the right track, let me actually show you what I have so far. That's what I have so far. So when I factor, I got 3x plus 1 times x plus 4 for the first denominator. The second denominator had x minus 7 times x plus 4. Do the two denominators share a factor? Absolutely. They share x plus 4. So what is the true LCD? The true LCD is only have 3 factors. The true LCD for this is going to be x plus 7, because you have x plus 7 somewhere. 3x plus 1, you have 3x plus 1 somewhere. And they both have x plus 4 in common. Like, for example, what if you have like 1/8 plus 1/6? What's the LCD for 8 and 6? Is it 48? It is common, but can we go smaller than 48? What's the least common multiple or least common denominator for 8 and 6? What did they both go into, but smallest? I know someone knows this.
Wait, what?
What's the least common multiple of 8 and 6?
3, 4.
Good, exactly. So when I do this, I wouldn't multiply this by 6 and 6. I'd multiply by 3 and 3 to avoid fractions that are too large. Likewise here. So even though you don't necessarily combine both fractions as they are, you try to find common factors and avoid duplicating that. So that's why we do x plus 7, 3x plus 1, x plus 4. We don't just multiply the two quadratic expressions together. That's just crazy. Factor it and see what you need. Try to be a minimalist here, right? So you make this problem easy for yourself. So that's how you get started with part A. I'm gonna work out part C, and then I'll get to your question. Okay. Ben, show me your question. You're on a track, pushing positive x squared, not negative x squared. Minus negative, right? You guys should both. That's probably why you're not there. What's that, Super Mario Brothers on? Oh, yeah. Wow, how do you get that? It's like, that's right. Yeah. Okay, so that's good.
Let's figure so look at your. Yes, bro.
I got 27.
Yes, bro.
You guys have all right.
Please,
Oh, I gotta work out the other one too. Hold on. You have a question, Paul? Give me 1 second.
Like, I have my history test.
You ready? Was it on?
I'm almost ready. I just have to like know what caused the Civil War. And
It's a big one.
kind of big. It's nice to know all the stuff and I have to know it about. And like a minstrel. Minstrel. It's like the shows that like. No.
1 second.
I know, but my mom's. What's on that? What the question is? Yeah. Yeah. Mine's what caused.
Is this the right answer for A? Or B?
It should just be x minus 2 over x minus 4.
So how do you get rid of the 5?
5 for C. I think that's
No,
5.
for B. For B.
Oh, for B. Oh, no. It's x minus. Your denominator should be bigger. Should be more stuff going on there. Should also be x.
So where's the denominator?
Yeah. Your LCD is this, right? 3x plus 1, x plus 4, and x minus 7.
Yeah.
You're not going to cross those off because you need the same denominator to combine the fractions.
Yeah.
Yeah. Your denominator is all this chunk here. That should be in your final answer.
Oh,
They don't cancel out. How do they cancel out?
okay.
Because then you're going backwards to what you had before,
Mhm.
right?
Okay, I see it.
Yeah.
And then for C at least.
Yeah, keep going. You got to factor that x minus 4, x plus 4.
Oh yeah. And then
X minus 4 is cancel, right?
But x plus 2.
Ooh, I don't get that though. Hold on. You know what? You're right. I'm wrong. Hey guys, I messed up for the part C. You got it. You're right. I'm wrong. Guys, I messed up my part. Yeah, let me fix this. I made a mistake here.
Does this look right?
Hold on. I'm just gonna redo this. It's on part C or part.
I'm just like just built the whole like.
Give us a call. I'll come by. Give me a sec. All right. My apologies for the mistake I made on part C. So yeah, the answers. Let's talk about part C because that one's a little bit easier to read. My answer for part A is kind of all over the map. So for part C, again, Ellie, can you get that? For part C, you have 2 over x plus 4 and you have 4x minus x squared minus 16. You factor in x was numerator of the second fraction. The denominator of the second fraction is x minus 4 plus 4. The LCD is x minus 4 times x plus 4. Both got x minus 4 both top line of the first fraction. So you get 2x minus 8 with all that junk minus 4x plus x squared. So you get the minus both 4x to negative x squared, to negative 4x plus x squared. Combine everything, you should get that. That's factorable further. X minus 4, x minus 4, x plus 2, x minus 4 is go away, x plus 2, x plus 4 goes again. You can also plug in a number, as I said, plug in 1, see if you got it. But plug in 1 here, I get 2/5, right? Plug in 1 here, I get 3 over negative 15, which is negative 1/5. So you get 3/5. Plug in 1 here, yeah, there you go, I get 3/5. I know I did this right, so I feel good about my answer for part C. Part A is more involved because there's 3 factors in the denominator or the LCD. So when you factor the first denominator and second denominator, we get x plus 3x plus 1 x squared red, x minus x plus 4 red. So you're missing x minus 7 from the first fraction, plus 3x from the second fraction. Multiply by what you're missing, line everything. If you do everything correctly, you should get 5x squared minus 5x plus 10 on top. I got lazy, I did a little quotation marks, so I'm repeating the denominator. And then I pull out a 5 after. But nothing really goes away. Even if you factor, so you just leave it like that up in the right corner or whatever is there. we're cool? We're good?
Mhm.
Okay, cool. Perfect. Okay, so I'm done with the notes. So again, it's very mechanical stuff we're doing, just combining fractions. That's what you're doing. Homework is on the next page. Put some extra practice problems if you want it. I put enough space. You could actually do the homework on this worksheet and then take pictures if you want, because I probably have enough space. The answers are at the end of the packet. You guys have it all. The group quiz is now. Yes.
Let's do it.
And all multiple choice. Yeah. It's free response this time, not multiple choice. And guys, I'll have you join Jack, Sarab, and Ben. Then I'll put you together. Yeah, I know. Hey, seriously, you guys are hungry. Help yourself. It's like eating pizza. It's good. I'll be in all. That's my favorite. So. Sorry. I should got 2 orders of it. I'm sorry, guys. We get updated. Not backwards, so you have to look at the square. Take half of the.
Wait, what? Doesn't show these two kids now.
I don't think so. Yeah, things should cancel out nicely for part A, or number 1. But number 2 is a little weird, but clean it up.
Do you multiply these?
Well, things should cancel.
Well, I already canceled them, but.
More cancels.
What?
More cancels.
Can I?
Factor completely. Yeah, go ahead. Totally, do it.
Oh, if you take 4 out, then it
Yeah.
becomes 2x.